Calculating K gives an indication at which a chemical reaction proceeds when at equilibrium. Consider the production of hydrogen iodide. 1 mole of hydrogen gas and 1 mole of iodine gas are introduced into a 1 liter container. The reaction does its thing and reaches equilibrium at 445 degrees Celsius, showing 0.2 moles of hydrogen gas and 0.2 moles of iodine gas. At 445 degrees Celsius, K equals 55. The question is, how many moles of hydrogen iodide were produced? To work this out, we use a technique called ICE tables. This stands for initial, change, and equilibrium. Let's try it out on this. So our balance equation is given. Initially we have 1 mole of hydrogen gas, place it here, 1 mole of iodine gas, and no moles of hydrogen iodide, since the reaction has yet to proceed. At equilibrium, there was 0.2 moles of hydrogen gas and 0.2 moles of iodine gas. Therefore, there was a change or decrease of 0.8 moles. That is 1 minus 0.2 for both reactants, as they're both 1:1. This means there would have been a change of 0.8 times 2 for hydrogen iodide, and it's times 2 because it's in a 2:1 ratio with the reactants, which is 1.6. Therefore, at equilibrium, the molar concentration of hydrogen gas and iodine gas is 0.2 moles per liter, and the molar concentration of hydrogen iodide is 1.6 moles per liter. Remembering these values are all calculated when the volume is 1 liter. If it's not, you'll need to convert them. Let's plug these values into its equilibrium expression. So it's products over reactants, or PORC. K equals this, then this. So K equals 65 at 445 degrees Celsius. Here's another example. Consider the equilibrium of acetic acid. Its K is 1.8 times 10 to the negative 5. Now that's a really small number, which means equilibrium lies far to the left. Very little reactant would form products, so effectively you would end up with loads of unionized acetic acid molecules. So the question is, if a 0.5 moles per liter solution of acetic acid is made, what would be its pH of the resulting solution at equilibrium? What a conundrum. Okay, let's make another ICE table. Initially there will be no product, so that can be filled in. Because we don't know how much reactant has ionized and it's unknown, we'll call it X. So the change in reactants will be 0.5 minus X. This means at equilibrium, the concentration is 0.5 minus X. The change in products will be plus X. Therefore, at equilibrium, both products will be X. Let's plug these values into the expression. We can proceed to solve the equation using quadratics. However, knowing that K is super small means X is also super small in comparison to 0.5. So we can make the approximation that 0.5 minus X is really just 0.5. It's a bit like pulling one single eyebrow hair. This won't change your mass too much. So by forgetting the change of X, we can recalculate the expression like so, which leads to this. So the hydrogen ion concentration is 3 times 10 to the negative 3. Therefore, pH equals the negative log of this, which is 2.5.